So without further ado, I want to jump in and think about orchestrating generative AI workflows and what this even means. So thinking about really the full stack of generative AI. But first, I want to think about how we build machine learning software, right? And how that changes from building traditional software. Okay. So in order to reason through this, I want to think about the stack of machine learning software, kind of all the tools we need to use, right? So let's think through how it differs from traditional software. And to do that, let's start looking at traditional software. So you have a software engineer and some sort of software system, ideally a valuable system. We can think of how to slice this in a variety of ways. But two things that we definitely require of any software system is that it will run reliably without human supervision. So were I to build it and wanted to go and have dinner and close my laptop, we'd want it to run reliably for you or the end user. We also want it to produce correct results. So these are two incredibly important aspects of any traditional software system that we still require when we go to machine learning and data and AI-powered software, right? But what changes within this system? So we have several new components, right? We have data, we have machine learning models. We also have a new role of a data scientist and a new role that has a vastly different skill set as well. The skills of a data scientist are very different to the skills of a classical software engineer, right? So we're going to see how that's important in terms of kind of the stack that we interact with as data scientists and machine learning engineers. So what are the building blocks that we then have, right? We have data, models, and code, and they need to interact in a variety of ways. So now we're going to see kind of the implications of the requirement that they interact, right? So in order for our data to interact with our models, we require computation to happen somewhere. You know, when doing exploratory data analysis and first experimenting with models, that compute may happen on your local workstation, on your laptop. But after a while, particularly if you're doing generative AI stuff, which is compute intensive, maybe you're going to start leveraging cloud resources. So compute is essential. On top of that, orchestration becomes increasingly important. And that's why we called this talk orchestrating in a lot of ways, right? That when you write code to build models, you know, you can do fit and predict, do some feature engineering, these types of things using, you know, your favorite wonderful packages such as scikit-learn or XGBoost or PyTorch, right? But there comes a point where once you're putting models in production, and we'll talk about what that means soon, but once you're putting models in production, you know, maybe you're doing massive hyperparameter optimization, feature engineering, data validation, training different models on joins of different data sets, these types of things. And you want to start putting orchestrating these models through the code by putting them in some sort of graph. If you've had experience with data engineering or these types of workflows, maybe you've seen directed acyclic graphs or DAGs, but this is kind of the standard of how we think about orchestrating machine learning models as well. But orchestration becomes increasingly important. Now, as I said, these models are built by humans such as yourself and myself, right? With a particular skill set, a scientific skill set, one of iteration and rapid prototyping, right? So when building models, maybe you're jumping in notebooks at the start in order to rapidly prototype your models, and you're generating a lot of data yourself. So you need to start thinking about versioning. Now, not only versioning your code, you may have versioned code before, but now you're thinking about versioning all the data that you're working on and versioning your models as well. So let's say you've got a model in production at some point which produces an incorrect result, and you want to root cause this, essentially figure out what happened. You want to be able to trace it back to the data, to the actual model you used, the run that you used when you trained it, and then the data that it was trained on. Perhaps you have data that's updating daily, right? So you want to go back and be able to find the actual data set that you trained it on. So versioning is increasingly important. Now, to connect all of these things to your valuable software system, you need to deploy the model in some sense, which, you know, a lot of people think of this as productionization, but of course, this entire process is really thinking what it means to have a model in production. Now, the deployment story, I think a lot of people tend to think this means setting up an API that people can ping, or you can, you know, build into an application, right? Something like that. That's one of many ways to deploy a model. A lot of models involve batch inference, where, you know, at the end of a day or end of a week, the models run, and all the predictions are stored in a data warehouse or something along those lines. Or you can have you know, the deployment story told by a slide deck being generated and sent to executives that then use it to make business decisions, or a weekly email that's generated and sent to the team. So deployment, all I'm really saying there is that deployment can take many forms and flavors. So then what has emerged here is a more nuanced view of the machine learning infrastructure stack. And we're about to get into, you know, what changes and what doesn't when we work with generative AI, right? But we have data at the bottom, then compute, orchestration, versioning, deployment, modeling at the top. And the truth of the matter is that, you know, there's a lot to work with here, and a lot of different things need to be done. And data scientists really care about the top of the stack, but a significant amount of infrastructure is required at the bottom. And you may say, wait, Hugo, it looks like you're saying data scientists don't care about data at all. And that's not what I'm saying at all, but it's a great question if that came to mind. I mean, it's a great question anyway, and I hear it a lot, right? But the point here, of course, data scientists care a huge amount about data. What isn't necessarily their most important concern is how the data engineering pipelines work, whether it's stored in a data warehouse or coming from Parquet files on S3, these types of things, right? And if a data scientist does start to care about these things significantly, to be honest, they're kind of becoming a data engineer, and that's totally cool. And actually, I support a lot of data scientists who transition to data engineering roles. And I've seen this happen a lot, right? But really, I'm talking about the data engineering side of things here. And so, of course, data scientists care about data, but they want to use it for a very practical purpose, which is to build models and put them in production. So in a second, we're going to jump into generative AI, but I wanted to talk about Metaflow, which is an open source framework that I work on with my colleagues at Out of Bounds and Netflix. So this is a framework that my colleagues, when they ran machine learning infrastructure at Netflix, built in 2017, then open sourced in 2019. And now it's used by hundreds of companies all across the globe in all types of verticals. But I wanted to show some Metaflow code just to give a sense of how you can, I mean, this is PyData. I want to give a sense of how you can write Pythonic code and Python code, not only Pythonic, but Python code, but Pythonic as well, in order to interact with the full stack of machine learning in this sense. So what we have is we're writing a class and we're subclassing FlowSpec here, where the steps in your machine learning workflow, we've got two steps here, start and end. So this is a very simplified example. But what we see is that to tell the modeling part of the story, right, there's a decorator at Condabase where at a flow level, you can define the libraries that you want to use. So we've got a particular version of scikit-learn here. Okay, you can also define, if you have different packages at different steps, you can define them. And maybe, for resourcing, you want to do that at different steps. In terms of deployment, you can use lots of different decorators you can use, but at schedule, we'll make sure that this is deployed daily at a particular cadence. And there are defaults, but you can also specify what you'd like to. In terms of versioning, if you assign a variable to assign an in here, for example, to an instance variable, this will make sure that self.x persists across steps, and also that it's stored in the metadata service. So you're able to, after the fact, access all of these variables. The whole thing is the directed acyclic graph. So the whole thing is the orchestration story. In terms of compute, if I didn't have this decorator, by default, all of this would run locally. If I have a step such as, let's say I want to do some pretty significant, generative AI training, for example, I can use an Kubernetes decorator and specify the memory that I require in order to send that to the cloud. And in terms of data, this is once again how we interact with data. So we're incrementing self.x by 1 here. And you can work with all types of, data and data types from all types of data warehouses and Parquet files and all of these things. But what I want to make clear is that my background is in research science, and I want to make sure that scientists have access to the tools, software tools that help them do their work the best. So I want to make sure that data scientists and ML engineers aren't required to go and work with gnarly Kubernetes clusters and set them up and write configuration files in YAML and all of these types of things. So that's why I'm really excited about, this type of Pythonic decorator-based resource acquisition. So being able to write at Kubernetes in order to get access to a cluster that's been provisioned for you is super important to me as a human. So all us scientists can do our best work. And very happy to chat more about that type of thing. But we're here to talk about generative AI, right? And by generative AI, I really mean all the wonderful LLMs we're seeing, all the speech to text, all the like text to image, text to video, all of these incredible things that we're seeing. So how do these things change data workflows currently? Okay, so firstly, I think it's important to just reason through, and a potentially example. There are many ways we can think about this, but we know, for example, that a lot of the time we'll be pinging vendor APIs and/or using open source foundation models. So in this example, we have a customer service chatbot and a product that's powered by a lot of this generative AI stuff. So we have an open source foundation model, which we're fine tuning the large language model, then using it to generate some embeddings, and then powering a customer service chatbot using this. We also have stuff coming in from a data warehouse. This may be prompts or themes or whatever it is. These things are also feeding personalized recommendations, which are being stored in the same or a different data warehouse, which are then used to power a product. The product also involves image generation, which we're getting from a vendor, and we're generating images, putting them in cloud storage, and using that to power the product as well, right? Now, one thing I want you all to be thinking more and more about is the risk you're taking on and the cost when adopting such things as AI vendor APIs and open source foundation models. So, for example, thinking even through latency concerns, cost, future-proofing what you're doing, because these things are outside your governance boundary. You do not necessarily, like there are terms of service with AI vendors, but you do not control what their models are or what's happening there. And similarly, open source foundation models, perhaps you have a bit more knowledge of what's going on, but a lot of the time, open source, you don't even know what the training data is, but you do have access to the weights and not necessarily the code. So start thinking about the type of affordances, risks, and benefits of what you're taking on. And also, I just wanted to say, I'm seeing. Hey Tom, thanks so much. Great to see you watching from Austin. But I just want to say it's so cool to have so many people from. We've got UK and Greece, Seattle, Austin, Hungary. It's really cool to see a whole bunch of people from around the world, a lot of countries represented here. So great to see you all. So in terms of the stack, we've got data, versioning, compute, orchestration, modeling, deployment, all these things, right? The question is, does the stack remain the same when we move from machine learning to generative AI? And I argue that it does. Some of the details differ a lot, but we still, data is a foundational concern. We require our data to be flowing in DAGs. We require secure access. We require fast cloud APIs. Similarly, compute is important. And you may say, and I would totally agree, that although these things remain the same, some are weighted more heavily now. So currently, compute is even more important, right? So we need pretty serious processors and GPUs, parallelization, low latency APIs. We definitively need to still be telling the orchestration story. We need to be reacting to new data. We need to be handling failures gracefully. We need to be able to checkpoint and resume our flows as well. The versioning story is still incredibly important, if not more so. Not obvious to me how this will play out. I mean, of course, we need to version our prompts and have prompt management. We need to have, different and isolated namespaces so we can trace back and see what's happened where. We're generating a lot of artifacts that we need to version as well. And what I mean is, well, I'm not sure how this is going to play out, is in the versioning story pre-generative AI, a lot, not all, but a lot of what we were generating is quote unquote structured data, right? And now we have a huge amount of natural language and images and videos that we're generating. And it's not clear to me that more and more we're creating like natural language data, how we want to think about versioning. And so it's fascinating, but it's kind of scary in a lot of ways as well. Maybe that's it's, as I said, it's 8 a.m. on a Saturday, so maybe I'm prone to fear more than at other points in time. But I do think it's challenging. The deployment story is still, of course, key, and so is modeling, right? People still want to use their favorite packages. We've got really cool open source foundation models now to use. Increasingly, we're thinking about calling external libraries and AI vendor APIs, which is kind of a new part of the story. When doing full stack machine learning, most of the time we're using open source packages, right? That's no longer the case now. And you want to do all of this in a manner that makes engineers happy too, right? So in the final 10 minutes, I want to talk about the types of generative AI systems that we're talking about, and then some key concerns, okay? So it was like last August, maybe earlier, last June, that Stable Diffusion came on the scene and kind of blew us all away. And these are some images we generated with Metaflow at Out of Bounds of Nicolas Cage as Thor, Superman, Hercules, and The Godfather. I never quite got my own joke here. Of course, you may know that Nicolas Cage is a Coppola. He's Francis Ford Coppola is his uncle. So it even makes even more sense to put him as the Godfather there. But this is compute intensive stuff, generating these types of images. And so what we did was, there are a lot of proof of concept around at the time, as there is with a lot of generative AI, not a lot of being able to productionize it. So what we figured out and published, and you can go to our blog, and I've got links at the end of this talk that I'll show you, and you can go to, of how to parallelize Stable Diffusion for production use cases. And these are types of DAGs I was talking about recently, where you upload the model to S3, then you generate images in different styles as here, then you paint the cards, then you join the cards, join the style, and you can see, we're using Hugging Face and Docker and NVIDIA GPUs and that type of stuff there. So now this is, you're getting a sneak peek into something we haven't published yet, that we'll publish, I think, in a few days. So definitely ping me on Slack. I'll send you a link to our community Slack at the end of this talk as well. But a few weeks ago, Stable Video Diffusion was released, which is image to video. And these are images we've generated. This is wild to me. I don't want to, Stability AI released Stable Video Diffusion a few weeks ago. Then we were attempting to replicate our Stable Diffusion work in video. Then they released Stable Diffusion XL, which is a new version of Stable Diffusion, and we're able to switch that out pretty much immediately, which is super exciting. But if you have access to compute and kind of robust orchestrators like Metaflow, you're able to generate these types of things with relative ease. To be clear, and I mean, these images are sorry, these videos are pretty. I wouldn't quite say it's Pixar or Disney level, but I mean, some of them are getting really close. So I think it's a fascinating space. And so we're building an app which, in the end, outputs things like this that you can play around with. But it starts with prompts and themes. You want to load your data, then use text to image and image to video to generate the images, serve them to cloud storage, and then have them accessible. This is a DAG of the types of things we're doing, where you can see, once again, we upload the models, generate images, generate videos from images, join subjects. And this is some pseudocode. Well, it's pretty close, where we have data in our data warehouse, and we trigger it. Then we generate the videos, and then we have our GPUs and visualization and clusters up there. So this stuff is a lot of fun to work with. So keep your eyes peeled. We've also been doing work with speech-to-text models such as OpenAI Whisper on Kubernetes to put them in production, which is super fun. A lot of large language models, so fine-tuning LLMs, which this is essentially taking foundation models and then making them work on more specific data sets, so that they can become more specific and more relevant to your actual concerns. Another technique for doing this, which doesn't require anywhere near as much compute as fine-tuning, is a really fun technique that that we spent half of a workshop we taught here at PyData Global on yesterday, going through. So the basic idea is it's a way of controlling LLMs and making the output a lot more relevant by approaching the problem at inference time, not during training. So you essentially index a knowledge base and use it to increase the relevance of LLM responses. So we did an example where we asked ChatGPT, how do you specify packages for a machine learning workflow? And it gave us a general answer around Conda. We wanted a Metaflow specific one. And so we used retrieval augmented generation with all the Metaflow documentation to get out the answer. And it gave us the at-Conda based decorator that I mentioned earlier. So I do want to speak to a few challenges and then how we're thinking about ways forward. One of the biggest concerns is that large language models tend to hallucinate, and we'll go into what that means in a second. We've got data freshness issues we need to constantly update, questions of closed versus open APIs, and then the cost of fine-tuning. So in the final 5 minutes, we started 5 minutes late, so we're going to go five minutes over. But what do we say when we mean hallucinate? And what I mean by that is, left to their pre-training data sets, generic LLMs will gladly generate nonsense. And this is work we did with our collaborator Federico Bianchi at Stanford. And so that's him there. And so he asked, how do I specify Conda dependencies in my flow, in Metaflow? And this answer is wrong. This is nonsense. But if you didn't know, perhaps you'd try it and not know. So the level of deviation from any trusted database is actually unacceptable. So how do we then figure this out? And we can deal with it by what I mentioned earlier, this idea of fine tuning or in instruction tuning here. Okay, so we can continue training the model on a much more tightly curated data set, teaching it how to do specific things like follow these instructions. So compared to the size of pre-training data sets, this can drastically narrow the model scope and lead it to generate far more relevant responses, which is super cool. The other way that I already mentioned is using retrieval augmented generation. Oops. Another challenge is that models don't have access to fresh data. So, it's depending on, when ChatGPT is updated recently for you, it may be, most recently trained on 2021, 2022, or more recent data. But a huge problem is that these models aren't necessarily always updated. So how do we think about that? And what we can do is put highly relevant data in databases and use, for example, our at-schedule decorator in order to do instruction tuning, fine tuning, and or retrieval augmented generation on a regular cadence in order to update our large language models so that they have current and relevant data. Now this is a fun one. There are so many models. I'm pretty sure by most metrics, AI is the fastest moving technology in human history. So in order to stay in business, we need to increasingly learn to adapt and figure out what's happening in the space. A lot of the time, the commercial APIs are expedient. Open source requires more effort, but open source also lets you own more of the supply chain and have more control. So as I mentioned before, thinking through, performing a cost benefit analysis of what models you're using and why is incredibly important. Right. And one way to think about, solving the challenges here are to reduce dependencies on single points of failure in the software supply chain, right? How we think about that at Metaflow and Out of Bounds is making sure that you're able to swap models in and out. So this is an example of swapping out Lance DB for Pinecone. Another one I saw recently that we have there are some Metaflow users here in Sydney actually who I gave a talk with recently. They've got an online learning platform called Atomy that's used in a lot of high schools. Super cool stuff. And they were using ChatGPT, and they recently switched it out with almost no migration cost for Llama 2, which is an open source model from Facebook, from Meta, company formerly known as Facebook. So thinking about making these easily composable flows where you can switch things in and out is increasingly important. Cost is really important to think through. And when we're doing fine tuning, it's something that you really need to consider because it can be incredibly expensive. And so thinking through reducing costs from model optimization, using such techniques as quantization and LoRa, low rank optimization. And this is kind of a whirlwind tour of these types of things, but when you start implementing these things, these are the types of things you need to think about. So just to recap, and then we'll wrap up, the challenges that LLMs hallucinate, you can solve that and think about solving that by augmenting its context with your data. Data freshness is a challenge that you can think about scheduling and event-based workflows for updating your models. To think about closed versus open APIs, we have reusable workflow abstractions, which allow they're modular and allow you to switch out closed and open models for each other. And to work through and solve the expenses of fine tuning, you want to think a lot about model optimization. So to wrap up, I'd have to fire myself if I didn't tell you how you can do this at home. Check out the Metaflow documentation at docs.metaflow.org for all the open source stuff. Also check out the sandbox. So this is what we went through in the tutorial yesterday. Setting up a lot of the infrastructure stuff, such as Kubernetes clusters and deployments, is highly non-trivial. So we've built a sandbox where you can interact with all the open source infrastructure that we work on as well. You can think about it as like a Google Colab for machine learning infrastructure, full stack machine learning and AI, or you can think about it as kind of a super powered in-browser VS Code where you can write code, execute it. You've got your terminals, all of these types of things. And we have a lot of different tutorials that speak to a lot of the content I presented today. from audio processing with Whisper to computer vision, NLP, recommender systems, where we've set up everything, including Kubernetes clusters, for you to play around with. Okay, and finally, if you want to chat about this type of stuff, come and say hi on Slack. This is our Slack link. And actually, we've got over 3,000 data scientists and machine learning engineers all talking about all this fun open source stuff. And you can DM me or my colleague Eddie at Hugo at Eddie. But if you ask questions in public as well, then a lot of different people can answer them. So once again, thank you so much for joining. Thank you for sticking around until the end of the conference as well. And I'd love to thank PyData once again for having us. It's a real pleasure, always.
Thank you so much, Hugo. That was a great talk. I think I speak for everyone. Thank you so much for your expertise and your time. I really quickly want to bring to your attention one question. Great
Right.
presentation, Hugo. Will it be possible to get the slides from Ade?
Oh yeah. Why don't I will share this slide deck right now. Copy link, and what I'll do is anyone with the link cannot edit. I'll give everyone. Great question, and I've just pasted this in the chat. Would you, Samina? Would you just confirm that?
Yep, I see that.
Beautiful.
I'll go ahead and pin it too. I will
Great.
say that the chat gets cleared at the end of the session, but I'll leave a minute real quick and I'll say my thanks. So thank you so much for everyone joining today. As we close PyData Global, I just want to really profess my love for the community, and on behalf of all the organizers and speakers, thank you for joining us. I saw a question about seeing Hugo's tutorial recording from yesterday. So if y'all are curious or you missed a session that you were hoping to see in AirMeet, you can rewatch any session until the end of the year. We're giving y'all until January 1st, 2024. Afterwards, they'll be uploaded to the PyData YouTube channel. So you can find it there. And we have a feedback survey that would be awesome if y'all could fill it out in the Discord. Yeah, thank you again.
Awesome. Thanks, Samina, once again, and thanks everyone.
Real quick, sorry, Hugo, one more quick question. I just want to make sure we get everyone's bases covered. Musi is asking, what is your advice on the cybersecurity within the LLM Gen AI? Any link? Within LLM Gen AI, any links?
This is a really important question, and I think we don't have a strong sense of how it's playing out currently. I do have a link. Let me so I think one thing we think about a lot is software supply chains and vulnerability in software supply chains. So we've been working with a wonderful company called ChainGuard. I've just linked to a blog post from ChainGuard, but essentially this is a blog post around these types of questions about how adoption of open source tools and vendor APIs interacts with the type of security concerns you have. And I think one thing that's becoming increasingly important is to identify vulnerabilities at each different step in the machine learning supply chain. But check out that blog and come and chat with us on Slack about it as well, if you want.